Hello to everyone. Today we're going to be looking at lesson 95 together. The title of the lesson is Volume of a Right Solid. I think we're going to go ahead and just jump right into the lesson. And I don't think the lesson is going to take too awfully long today, and I'm pretty sure that you guys are excited about that. Okay, so let's talk about what a solid is. We talked about solids in a past lesson quite some time ago, maybe in the lesson 67 or 68 or something back at that time. And we said that a solid was simply a three-dimensional geometric shape. Okay, so today we're going to narrow that down to talk about what a right solid is and how we find the volume of a right solid. So let's get started by giving a definition for a right solid. Up on the top of your notes here, we're going to fill in these blanks. A right solid is simply a geometric, let's fill these in, a geometric shape whose sides are perpendicular to the base. Okay, we know that what perpendicular means is our lines that come down, for example, that's the symbol we use for perpendicular because it's two lines that intersect that make right angles. Okay, remember that's what perpendicular means. So when we're thinking about a right solid, we're thinking about a right angle. So the shape's sides come down and meet the base and they're perpendicular. So the sides come down, meet the base at a 90-degree angle. Okay, now to find the volume of a right solid, we would take the area of the base and we would multiply that with the height of our shape or our right solid. Okay, I'm going to bounce down here to the bottom of my document. You don't have this on yours. I'm just going to use this for just a moment to just kind of walk through a quick example of how we find the volume. We've actually been working on volume. It's just that this lesson is more specific to finding the volume of a right solid. Then we'll work through a couple of examples together before we end our lesson here so that you'll feel comfortable when you come across some problems in your lesson today. Okay, so here I have a right solid. It's a right solid because you can see that the sides come down and meet the base at a 90-degree angle. Now that cube, or that it's not actually a cube, but that rectangular prism is actually kind of sitting at an angle. So it may not look to you like it's coming down and making a right angle, but it actually is. If I were to turn that thing to be more facing forward, you would see it, but you know that's what it is. It's sitting flat on the surface. And so that is considered a right solid. So remember we said that to find the volume, we would find the area of the base and we would multiply that by the height. Okay, so I can look at my base here just with my eyes. You wouldn't even have to tell me what the measurements of this are. I wouldn't have to fill those in for you because you can look at this and see. We have 1, 2, 3, 4, 5 across. We have 2 this way. So my base on my right solid, I could fill the bottom up with 10 of those cubes that are measuring. I was told in this problem that everything is in meters. Okay, so I can tell you that there are 10 1-meter cubes filling up the bottom of the base of my right solid here. But let's figure that out by what it would look like with our math. So I would take 5 meters times 2 meters, and I would get 10 meters squared. That's the area of my base. And then I would multiply by my height, and we can see that our height is 3 meters. So I'm going to multiply by 3 meters, and I'm going to end up with 30 meters cubed because I've got meters squared and I have another meter over here. And when we multiply, remember we multiply our measurements, it ends up, we add up all the measurements that we have, which is a 2 here and a 1 here, gives me meters cubed. And volume is always a 3-dimensional object. We're multiplying by 3 different dimensions. We multiply by our length and our width and our height. There's our 3 dimensions, and that's another reason we can think of this as being to the 3rd power, or cubed, we would say. Some of you like to write it this way, and this is okay too. 30 cubic meters. Okay, so that's how we find the area of, or excuse me, the volume of a right solid. Okay, now back to our notes. There are two types of solids that I want to address in this, two types of right solids actually. Solids that have a polygon base, which means a flat base. Remember that a polygon is made up of straight sides. Polygon is closed. It's not a circle. It's like, it could be a square, it can be a triangle. As long as it has straight lines and it's a closed shape, then that's considered a polygon. So solids with a polygon base are called prisms. And we've talked about prisms in the past. Remember, a prism is something like, if I have a box, let's say, and I cut the ends off of it and I look straight, like think of a shoebox. If I have a shoebox and I cut the ends off and I look straight through that, I can see the shape of that rectangle continuing all the way through my solid. That's a prism. It has two bases that are completely, the opposite bases or opposite sides are always going to be the same measurement. Okay, so they're identical. That's a prism. So let's look over here. So this shape right here, this solid, this right solid is a right square prism. And then you also have here, you have a right triangular prism. So look at this triangular prism here. If you were to look through each one of those bases, if you cut those out and look straight through, like a tent, that would be like looking through a tent. If you're standing at the doorway of a tent and you're looking straight through, the same shape goes all the way from the front side of the tent to the back side of the tent. Okay, so that's a prism. But a prism is also has to have a polygon base. Okay, so that solid, these two solids are actually prisms. The other kind of a solid has a circular base, and I think about a can of Pringles or a soup can or something like that. Solids with a circular base are called circular cylinders. It's not a prism, even though I can look straight through. If I took on a Pringles can or a soup can, if I took both ends of my can off and looked straight through, yes, it's true that that shape is traveling all the way through. I can see that the shape doesn't change from one end of the soup can to the other end. But the fact that it does not have a polygon base is what makes that not qualify to be a prism. Instead, it's called a circular cylinder. Okay, so now what we're going to do is we're going to get to the nitty-gritty of this lesson, and we're going to do some examples here. So let's look at example 1. I've got a couple of drawings here. These came right out of your book, and I know they might be, well, they're hard to see here. I think you can see them okay in your actual notes, but on my iPad, when I expand that, it's a little bit blurry. Here's what the problem says. Find the volume of the right triangular prism below. Dimensions are in centimeters, and we're showing two different views of the prism. Okay, so the prism is laying on its side on one of the demonstrations of the solid, and the other solid, they've turned it so that it's resting on its actual base. How do I know that's the base? Because the bases have the same shape. That's what it's resting on this particular one. Okay, so it's sitting on the base. And so now to find the area, or excuse me, the volume of this triangular this right triangular prism, we have to find, first of all, let's write down what we said the formula for the volume is. So volume equals the area of the base times the height. Make sure you write this in your notes. So let's figure this out. So what is the area of the base? The two measurements. Okay, and I'm going to circle. I'm actually not going to circle. You might want to take a highlighter or maybe a colored pencil or a different colored pen and just highlight that section right here that you just saw me do in purple over here to the left. That's the base. All right, so when we're thinking about the base, this is what we're talking about right here. And maybe you can just write here, base. All right, so let's take the measurements of the base. The measurements of the base are 3 centimeters times 4 centimeters. And when and this is a triangle, so now we have to divide this by 2. Remember, the formula for the area of a triangle is base times height and divided by 2. Okay, so this is the area of the base, and we would get 12 centimeters squared divided by 2. I'm actually not going to write that in there. I think we know what that's going to turn out to be. It's going to end up to be 6 centimeters squared, because 3 times 4 is 12, and 12 divided by 2 is 6. I'll write that one more time so that I can make sure there we go. Okay, so we have 6 centimeters squared here. So volume is going to equal our 6 centimeters squared times the height, which is, and we can see a good clear picture of what the height is more so on this one, because it's standing on the base and you can see the height. So the height is 6 centimeters. And so we would get, for the volume of this right triangular prism, we would get 36 centimeters cubed. And that's the answer to example 1. Okay, now let's look at example 2. Example 2 is going to talk about the solid that we refer to as a circular cylinder. So I have a picture of a cylinder over here. Let's read what it says, as we need some dimensions on it. I have the picture but no dimensions, but the problem will tell us what we need to fill in here. The diameter of this right circular cylinder is 20 centimeters. Its height is 25 centimeters. What is its volume? And we're going to leave pi as pi. So that tells me that in the equation that we're going to use, we must have to have pi as part of the formula. Okay, so the height is going to be what's going up and down. This can, I'm going to refer to it as a can for just a moment, like a soup can, is sitting on its base. So this is the height, 25 centimeters. And then we're told that the diameter of the right circular cylinder is 20 centimeters. So what are they talking about here? Well, it's the base. And the base is the bottom here. I'm just going to kind of put it like this. The base is going to be, the diameter's measurement is given to us as 20 centimeters. So the base is the circle that it sits on. And then we also have an identical base. I could turn that can upside down. Both ends look the same. All right. So anyway, so we've got 20 centimeters on the bottom for the diameter of the circular bottom. Okay, so if you can picture that, that's what we're talking about here. So how do we figure out the volume? So again, volume equals area of the base times the height. I want you to write that in, please, again. So let's figure out what the area of the base is. All right, so really we're looking for the area of the circle. So how do we figure that? Do you remember what the formula for that is? Pi r squared. So let's figure out what that is. So we're going to leave pi as pi. So we have pi, and I need the radius. 20 centimeters is the diameter. Right? So we need half of that for the radius. So we're going to do pi times 10 squared. And that gives us 100 pi. When you write your pi, you should move that over to the right of your number. So we have 100 pi for the area of the base. And then we're going to multiply it times the height, which is 25 centimeters. Oops, I need to put centimeters squared over here. Let me just erase that so I don't have it squinched in there. Times 25 centimeters. And now I have that my volume is going to be equal to 2,500 centimeters cubed. And that's the answer for the volume of our right circular cylinder. Now keep in mind too, I want you guys to kind of think about, I didn't say this up here. I'm going to move back up to this part. When you look at a circular cylinder, see how this comes down and meets the base? that is making it's perpendicular. It's making a 90-degree angle actually down there. Even though it's a circle, when that side of the can actually comes down there, it's sitting at a 90-degree angle. So that's how come it can qualify as a right solid as well. That basically sums it up for our lesson today. I gave you 2 examples. You will come across one or maybe 2. I know you have at least 1 in your lesson. If you have any questions, again, you can reach out to me on Edmodo. I'd be happy to help. And that sums up the lesson. Thank you so much for watching. We'll see you soon.